Transmission and distribution. Like the name implies, it's a system that functions on two levels. As a whole, we know it's a delivery system to get the electricity from the power plant to the customers. So far, we've spent our time investigating the major components of the transmission side of the system: the switchyard and the transmission lines. Here, we're delivering power on a wholesale level, large quantities to relatively few locations. On the distribution side of the system, we have power delivery on the retail level. We're sending power in smaller quantities to many different locations, delivering it to the end-use customer. Between these two functional levels of the system, we have the substation. It's a clearinghouse where wholesale meets retail, where transmission meets distribution. Substations come in a variety of designs and a variety of sizes as well. But regardless of their size, they all do the same type of job. They receive electricity from transmission lines at a high voltage and reduce the voltage for distribution in a local area. At first glance, a typical substation looks like a cluttered, confusing maze of structures, conductors, and other equipment, but once you know what to look for, it's really much simpler than it seems. Where transmission lines enter the station, all of the insulators and bushings on station equipment are relatively large. This is the high voltage side of the substation. Where distribution lines leave the substation, the conductors and poles are also a lot smaller than anything you'd see on the transmission side of the system. Now that we know how to tell one end of a substation from another, let's take a look at the components that make it work. To make a substation, all you really need are station transformers, circuit breakers, and disconnects. First, we have to have the station transformer. In a sense, it's the heart of the substation. It's the component that reduces voltage from transmission levels to distribution levels. Transformers are generally the largest pieces of equipment in the substation. Each transformer usually has 2 rows of bushings on top of it, 3 large bushings on the high voltage transmission side, and 3 smaller bushings on the lower voltage distribution side. The next major components of a substation are the switches, the circuit breakers, and the disconnects. In both form and function, a substation is a lot like a switchyard. It just handles power on a smaller scale. The disconnects here serve the same purpose as switchyard disconnects. They are used to isolate equipment and lines for maintenance and repair. Circuit breakers are used to switch the power on or off in the substation. By opening and closing circuits, they also direct the flow of electricity to the appropriate lines for distribution. But there are some similar-looking devices in many substations that perform a very different function. This is a special kind of oil-filled switch called a recloser. In many substations, reclosers are part of the station's equipment for circuit protection. If there's a lightning strike on a distribution line or a fallen line, the recloser will open, and after a short interval, it'll attempt to reclose the circuit. If the condition is still present, the switch opens again. Many reclosers can be set up to attempt to close the circuit a certain number of times. Then, if the problem doesn't solve itself, the recloser stays in the open position, protecting equipment in the distribution system from damage. Sometimes, circuit breakers are used to perform the same type of protective function, but unlike reclosers, circuit breakers are not equipped to directly monitor conditions elsewhere in the system. For circuit protection, they have to depend on signals sent by external equipment. Often, the sensing elements and control equipment are contained in a small building on the substation grounds. Inside the building, there are racks and racks of equipment. There's sensing equipment to detect electrical faults, metering equipment so substation personnel can monitor conditions in the system, and control equipment to open, close, and regulate substation circuits. Some of the control equipment operates automatically, and some is designed for manual operation. This is an air circuit breaker. It's a piece of control equipment for manual or remote operation of substation circuits. Like other circuit breakers, it's basically a switch. It's called an air circuit breaker because the switch contacts inside are open to the air instead of being submerged in oil. A control device outside the enclosure can be used to manually operate the breaker. This indicator shows whether the breaker is in the open or closed position. Now that we've seen the types of equipment in a substation, let's put it all together. Get some perspective on how a substation operates as a whole. This simplified portion of a substation consists of a station transformer, 5 disconnects, and 2 circuit breakers. Now, to make it easier to see what's going on, we're using single lines to represent the 3-phase circuits you'll see in almost all T&D equipment. While 3-phase circuits are the most common in distribution equipment, beyond the substation, distribution circuits may be either 3-phase or single-phase. Right now, let's take a look at the normal path of power through the substation. To start, these switches will have to be closed. High voltage from the transmission circuit enters here. The station transformer reduces the voltage to distribution levels and sends it to a bus. The bus is simply a rigid conductor that connects different circuits within the substation. From the bus, power flows along this main circuit to another bus. From there, power flows out of the substation along distribution lines. Now let's say the main circuit breaker had to be taken out of service for maintenance or repair. While it's out of service, we'll maintain power to the distribution lines through the bypass circuit. Now here's the switching sequence we'll use. The first thing we want to do is establish a parallel path for current to flow through the auxiliary bypass circuit breaker and switches. First, we close the disconnects, and then we close the circuit breaker to actually make the connection. Now that we have the bypass circuit closed in, we want to open the main circuit. We open the circuit breaker first. Then we open the disconnects to isolate the circuit breaker from voltage on both sides. Now the main circuit breaker is completely isolated from all sources of voltage. It's de-energized and ready for maintenance or repair. Electricity still flows through the substation to the distribution lines by traveling through the bypass circuit. By closing the bypass before the main circuit was opened, we isolated the main circuit breaker without interrupting the flow of power through the substation and without putting any customers out of service. We've gone through a typical substation and seen some of its major components. From the substation, electricity flows to the final stage of its long journey from the power plant to the consumer. When we return, we'll be examining the components that deliver power directly to the homes and the businesses where it's used. We'll be taking a look at distribution lines and power delivery at the retail level.